Yes. Now, I think my screen is visible to all.
Yes, sir.
Now, in the previous class, we discussed about the hmm, basic number system. Then after that, we start with the negative number representation. So basically, in the case of binary, we have three types of representations. Binary number system. We have a three type of representation. One is for a negative number, one's complement, two's complement, and signed magnitude. Okay. Basically, in the case of first, we start with the signed magnitude. If, like, for example, -8 is represented, okay, -8 in decimal, I have to represent into the binary. So, in the case of signed magnitude, the MSB bit is used to define the sign, okay, and remaining bits will be the binary number of 8. Okay. Now, how MSB bit will be defined? So, if number is positive, the MSB bit is 0. If number is negative, the MSB bit is 1. Okay. So, if I want to represent a -8, so 8 should be the 1000, and this is a 4-bit representation of 8, and I add one more 1 to represent that this number should be the negative number. So this is the representation of -8. Okay, this is the representation of -8. Now, if you see that in a normal binary number, if n bit is defined, okay, if n bit is defined, so my range should be 0 to 2 raised to power n minus 1. Okay, and total number should be 2 raised to power n. For an example, if 4 bit is redefined, I can define 2 raised to power 4, that is 16 numbers, and the value from 0 to 2 raised to power n minus 1 minus 1. Sorry, 2 raised to power n minus 1 and 2 raised to power n minus 1. That means 0 to 50. Okay, 0 to 50 in a normal binary number. But in the case of signed magnitude number, for n bit, my range should be 0 to, sorry, not 0, minus of 2 raised to power n minus 1 to minus of 2 raised to power n minus 1 minus 1 plus. Okay, that means if minus 15 is defined, so the number of minus 15 is 1 because of minus sign, and 15 is 1 1 1 1. So with 5 bits, maximum number should be minus 15. Minimum number is minus 15. And if plus 15 is defined, so the MSB is 0 and 15 is 1 1 1 1. So minus 15 to plus 15 is the range. Okay. So minus of 2 raised to power 5 minus 1 minus 1 to plus 2 raised to power 5 minus 1 minus 1. So minus 15 to plus 15 in the case of signed magnitude. Is it clear? Any doubt in this?
No, sir.
Okay. Now in the case of ones complement, again positive number is represented as the same and negative number we have to take the ones complement. Okay. Now like for example plus 7 is defined. So the representation is 0 1 1 1. Okay. Where the MSB has that number is positive or negative. If MSB is 0, that means number is positive. And if MSB is 1, that tells the number is negative. Okay. And minus 7 should be defined as a, first of all, 7 0 1 1 1. Then we have to take, because if it is a minus, so we have to take the ones complement. So 0 0 0 and 1. This is the representation. Okay. Plus 7, it is a 0 1 1 1, and minus 7, it is a 1 0 0 1. Okay. Now if 8 is represent, plus 8 is represented, so plus 8 is 1 0 0 0. Okay. Now 1 MSB will be defined that the number is positive or negative. So if MSB is 1, so we consider that this is a negative number, but here it is a positive number. So that's why I use one more bit here to represent this number is positive. And similar case, if minus 8 is defined, so 1 0 0 0. Okay. Now if I take a ones complement, so it become a 1 1 1 0. Now 0 define that it is, this number is positive, but this number is negative. So what should I do? I just apply the 0. Now take the ones complement, so it is a 1 0 0 1. So with the help of 4-bit, my maximum range that I can define is minus 7 to plus 7. Minus 7 to plus 7. So I can range it that maximum number that can be defined is minus of 2 raised to power n minus 1 minus 1 to 2 raised to power n minus 1 minus minus 7 to plus 7. Is it clear? With n bit. Okay. Now the problem with the signed magnitude and the ones complement. We know that either I can write a plus 0 and I can write a minus 0, both are same. Because for the 0, plus and minus doesn't matter. Okay, so either I can write a plus 0 or either I can write a minus 0, both are same. But in the case of sign magnitude, if the number is plus 0, so I can write as a 0 0 0 0 in a 4-bit and the MSB to define that this number is positive. Whereas minus 0 should be defined as a 4-bit for the 0 and MSB should be 1 to define that this number is a negative. So that means in the case of sign magnitude, plus 0, binary number of plus 0 and binary number of minus 0 is different. That is a problem. Problem with sign magnitude. Okay. Problem with the sign magnitude. Similar problem will come with the ones complement also. The plus 0. So I can write as a 0 0 0 0 4-bit minus 0. So we have to take the complement. So it become a 1 1 1 1. Okay. So in case of ones complement, binary number of plus 0 and minus 0 is big. Is it clear?
Yes.
Now we go to the third one, that is a 2's complement. Now we start with the plus 0 and minus 0. So if plus 0, so I can write as a 0 0 0 0. If minus 0, the number should be 0 0 0. So in the case of 2's complement, binary number of plus 0 and minus 0 is same. So the problem with the sign magnitude and one's complement, that will be eliminated with the help of 2's complement. Now, if I written as a plus 7, so positive number, no change. So plus 7 is 0 1 1 1. If I write a minus 7, so first of all I write a plus 7, then take a one's complement, so it will become a 1 0 0 1. Sorry, 1 0 0. Now add a 1. So 1 0 0 1. So that is for minus 7. Now similarly for plus 8, 1 0 0 0. Okay, so this is the problem. Plus 8, no need positive number, so no changes. Now from this number we can see that MSB is 1. So that defines define the number is negative. Number is negative. Okay. Now minus 8. I can write a 1 0 0 1 0. Now I should write a 8 take a 1's complement, so 0, 1, 1, 1 plus add 1. So 0, 0, 0, 1. Okay. So define the number is negative. And that's true. Okay, and that's true. So basically, with the n bit, with the 4 bit, first of all, with the 4 bit, I can represent from -8 to +7. Similarly, with the n bit, I can represent a minus of 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. Okay, why this happen? Because in the sign magnitude and in the ones complement, +0 and -0 is defined. Okay, +0 and -0 is defined. So -7, -6, -5, -4, -3, -2, -1, -0, 0, 1, 2, 3, 4, 5, 6, 7. So total how many numbers? 3, 6, 9, 4, 13 or 3, 16. Total 16 number is defined. So with the 4 bit, maximum 16 is possible. Now in the case of this one, +0 and -0 will be combined. Both will be represented by the same number. So one number is increased. Okay. And that number will be in the negative direction. It will be increased. Okay. Here it is -7 to +7. Here it is a -8 to +7 with 4 bit. Clear? Any doubt?
Yes.
Now extension. Like for example, I have to write a +7 into the binary. So the number is 0111. Okay, that is 4 bit number. 4 bit number. Now if I want to convert this 4 bit number into the 8 bit, so the thing is that just copy the MSB. Okay, so 0111 in 4 bit I can write as a 0000 because we have to convert this number into the 8 bit. So I just add a 4 bits. Okay, so just copy this MSB. MSB is 0, so I just take a 4 zeros, then 0111. Okay, similarly -7 in 2 bit, basically it is first of all 7 0 1 1 1, then take a ones complement 1 0 0 0, then take a plus add whose complement by adding the +1, so it become a 1001. Okay, if I convert this number into the 8 bit, so 0000 0111. Now take a ones complement, so it is a 1111 1000. Again adding 1, so it is a 1111 001. Sorry, 51001. So what should I do? I just copy the MSB. Okay, so it's -7 base 10, that is equal to 1001, or that is also equal to 11111001. Okay, so if we want to extend the bits, so the thing is that if it is a positive number or negative number doesn't mean, you just copy the MSB bit. Copy the MSB bit. Okay, so it is a way to extend the range in 2's complement. Extend the range in 2's complement. Okay, now the thing is that if any number is given 100100110, okay, any number is given, binary number is given, I have to take it 2's complement. So the method is what? Just take a ones complement first. Okay, so 0110110010, then plus add plus 1. That is a 01101101. Okay, that is a 2's complement. The direct way is that how we calculate the 2's complement. So start from the LSB where the first ones is come, till that no changes. Where the first one is coming, till that no changes, and after that repeat, basically invert all the bits. So 0 will be inverted into the 1, two ones will be converted into the 0, 2 0 will be inverted into the two ones, then 1 is 0, then two zeros will be 1, and then 0. So this is the 2's complement. This is the direct way. Any number. If this is a number, if I want to take a 2's complement, till first one, no changes. So 10 is same as it is. After that, change it. So two zeros become 2 1, then 1 0, then again two zeros, 2 1, and two ones, two zeros. This is the 2's complement. Clear? Any doubt how we can directly calculate the 2's complement? Two's complement. Again, till first one, no changes. So 1 0 0 as it is. After that, every bit will be removed. 1 1 0 1 1 0 0. Is it clear? Any doubt in that one? Just tell me.
Clear, sir.
Any doubt?
No, sir.
In the case of one's complement, the extension range. Like I just should plus 7, so it becomes a 0, 1, 1, 1. Now if I want to extend it up to the 8 bit, so similarly method is that I just copy MSP. That is similar. For the -7, I have to take the ones complement. So first of all, write down the +7, then take a ones complement. Now again the method is similar. Okay, no change. So just copy and paste MSP bit. In the sign magnitude, it is different. Like I have to write a +7. So MSB is 0, then 7. Okay. Now if I have to extend into the 8 bit, so MSB is 0, then 7. I can write as 0, 0, 0, 0, 1, 1, 1. So this is the 7. Okay. In the case of -7, it is a 1, 1, 1, 1 sign magnitude. One is the for negative sign and this is for 7. Now I have to extend it to the 8 bit. So MSB is 1. Okay, but I have to represent a 7 into the 7 bit. So it is a 0, 0, 0, 0, 1, 1, 1 in assignment. Okay, so the method in the ones complement, in the twos complement, and in the sign magnitude is different. Ones and twos are same. In the case of sign magnitude, we always enter 0 because if we enter the ones, so the number should be changed. The number should be changed. Okay. Now the one question that is arises in your mind that why we require this ones complement and twos complement. The requirement of this ones, twos complement and sign magnitude is that in the mathematics you are using the calculator. So in the calculator there is a plus sign is available, minus sign is available, multiply is available, and divide is available. But in the case of digital, only two particularly operation is possible. One is a addition Hello, am I audible?
Yes, sir.
Okay, so in the digital, the problem thing is that we required only two type of devices. One is the adder, and second is the multiplier. Okay, so addition and multiplication is possible. Now, if we use the subtraction, so how we do that one? Like for example, I have to do that 8 plus 6. Okay, so we can easily use the adder. Now, if the thing is that 8 minus 6, okay, subtraction is not possible. So what should I do? I just use that 8 plus of minus 6. Okay, so I just write the binary number as 2. Okay, so the subtractor, now subtraction will be done with the 2's complement of 6 add with the 8. Okay, so if I do the 8 minus 6, so we know that the answer is 2. Now if we do the 8 plus of minus 6, okay, so 8 is 0 1 0 0 0. Okay, 6 is what? 6 I can write down as a 0 0 1 1 0. Now I have to take the 2's complement, so just take a 2's complement. So how we take the 2's complement? Till 1 the number is same, after that the number should be changed. So this one is a minus 6. So I can write a 1 1 0 1 0. Now if I add these two, so 0 0 0 0 1 is 1, 0 0 is 0. Now 1 1 is 0 and 1 is carry. Now 1 0 is 1 and 1 is again 0 and 1 carry. Okay, if carry is coming, so the we just neglect this carry and this is the answer. So the value is plus 2. Okay, the value is plus 2. Okay, so that's why we require this complement, one's complement, two's complement, and the sign magnitude. Now, out of these three negative representation, the two's complement is accurate, better.
Sir,
Two's,
can we do 6 minus 8 so that we get a negative number
yeah.
addition?
So if we say do the 6 minus 8, so the number is minus 2.
Right.
Okay. So what is the representation of minus 2? The 2 is 0 0 0 1 0. And if I represent a minus 2, so it becomes a 1 0 1 as it is, till 1 is as it is, and after that, okay, invert every bit. So this is the answer. Now I just check with the binary representation of this one. So 6 is 0 0 1 1 0. What is 8? So first of all, I just write down the 8 0 1 0 0 0. Now minus 8. So till first ones, everything will be same from the LSB part. So 0 0 0 till 1. After that, invert the bit. Now add these two. So 0 0 is 0, 0 1 is 1, 0 1 is 1, 0 1 is 1, 0 1 is 1. Okay. Now if I convert into the binary decimal number, so first bit is negative 1, is that means negative number. Now take the 2's complement of this one. So how we take the 2's complement? Till first 1, everything is same. After that, it will be a invert. So this is the number of 2. So minus 2 is the answer.
Okay, sir. Thank you.
Okay. So that's why we require this complement. Now, similar way, if we required a for the decimal, generally in the books only the ones and twos complement is there, but for the decimal we can use the ninth complement, and tenth complement. For the octal, we do the seventh complement and eighth complement. And for the hexadecimal, we required a 15th complement and 16th complement. Or sometime we require we call that the E's complement, sorry, F complement and F plus 1 complement. The procedure is same. Okay. If number is given 7, 8, 9, okay, in the decimal, I have to convert it with the ninth complement. So what should I do? Just subtract with the 999. 3 bits, so that means 39. 7, 8, 9, 0, 1, 2. So this is the this is the ninth complement. Ninth complement. Similarly, if you want to calculate a tenth complement, so what should I do? Add 1. Okay, so 210, ninth complement, add 1, so it is a 211. That is a tenth complement. Okay, so ninth complement is similar to the ones complement. So how we take that ones complement? If any number is given 1010, how we take the we know that the one complement is 1010. But how we calculate it? We subtract this number with the 4 ones. So 1 minus 0, 1, 1 minus 1, 0, 1 minus 0, 1, and 1 minus 1, 0. So this is the ones complement. Now how we convert it with the twos complement? So plus 1, add plus 1, we convert it to the twos complement. So the answer is 0, 1, 1. Okay. So similar to the ones and twos complement, we have the nines and tens complement. Similarly, we calculate the seventh and eighth complement. How we calculate the seventh and eighth complement? 5, 6, 7 is number is given. Okay, or 5, 6, 5 is given in doctor. How we calculate the seventh complement? Three-bit number, so we have a 3 sevens. Subtract 5, 6, 5. 2, 1, 2. Okay, that is the seventh complement. Now, if we add a plus 1, so the answer is 2, 1, 3. That is its complement. Okay, and similar way we calculate the f and f plus 1 complement. So how we calculate the f? A1C. How we calculate the f complement? So 3-bit, so we subtract with the f, f, f. A1C. So f is 15 and c is 12. A is 10, b is 11, and c is 12. 15 minus 12, 3. 15 minus 1, 14, e. And 15 minus 10, 5. So that is a f's complement. Now if we add a plus 1, so 5e4. That is f plus 1's complement. Okay.
Yes.
Now, sometime in the competitive exam, they are asking that if any number 100 base 10. Okay, I have to find the base. 202. Hmm, we can take some different number. 244 base x. So we have to calculate the value of x. Okay. So if any base is given, like for example, if 101011 is given base 2, so how we convert this number into a decimal? Multiply and is addition. Multiply with weighted of twos. Okay. Multiply with weighted base and then add. So if I calculate the decimal number with respect to this one, so what should I do? 11011. Now multiply with weighted base. The base is 2, so 2 raised to power 0 plus multiply 2 raised to power 1 plus multiply 2 raised to power 2 plus multiply 2 raised to power 3 plus multiply 2 raised to power 4 plus multiply 2 raised to power 5. So it becomes a 32 plus 0 plus 8 plus 0 plus 2 plus 1. So it is a 43. Okay. Now here, if base x is given, so what should I do? I have to multiply with the weighted base. So 4, 4, 2. Now multiply with x raised to power 0 plus multiply with x raised to power 1 plus multiply with x raised to power 2. And that particularly value will be equal to the decimal. In the decimal, it is showing that it is equal to 100. Okay, so 2x square plus 4x plus 4 is equal to 100. Or can I write down the equation x square plus 2x plus 2 is equal to 50? Just divide by 2. Or if I take this 2 this side, so x square plus 2x minus 48 becomes 0. Okay. Now, yeah, this is a quadratic equation. You have to solve it. So x square plus 8x minus 6x minus 48 is equal to 0. So x plus 8 and x minus 6 becomes 0. Okay. So two possible values of x. One is the plus 8, sorry, minus 8, and second is plus 6. Now we know that negative is not possible. So this is not possible. Negative base is not possible. Okay, that means this is not possible. So what is the value of x? X is equal to 6. So we can say 100 base 10 is equal to 244 base 6. So this type of question is also available when you go with the any competitive exams. There the base is not defined, you have to calculate the base value. Okay.
Yes.
So I think we will stop here. If you have any doubt, you can ask me. Okay, so thank you all.
Thank you, sir.